Alrighty, happy day to you, whatever day you're watching it. We're gonna talk about section 1.8 here in geometry today. We'll do a little review of the midpoint formula, and then we'll get into this short section on perimeter, area, and circumference. So make sure you're writing down those goals every day, and the goal for today, and assessing yourself. The goal for today, if you want to pause it and write it down, is to find the perimeter, area, and circumference of some different basic shapes. All right. So, well, let's just start with a quick review. Midpoint formula of a coordinate plane. All right, that formula was your x1 plus your y, or x2 divided by 2, and then your y1 plus your y2 divided by 2. Basically taking the two x values and finding the average of it. That's your midpoint x value. And the same thing with the y's, because it will be right between the two points. So you're finding the averages of the x's and the y's to get your new x and y. So an example here, find the midpoint between the coordinates 2, -4, and 7, 5. I don't recall if we did this one or not. If we did, awesome. If we did not, even better. But let's just plug this in so you can maybe review how to do this. If you using the formula, you're just plugging in. It does not matter which one is your x1 or your y1. We'll just make this one x1 or x2. Make this your x1 and y1, and this one will be your x2 and y2. So if I plug in for that midpoint formula, I'm going to use 2 plus 7, divide that by 2, and have -4 plus 5, divide that by 2. So 2 plus 7 is 9, divided by 2 is 4.5, or 4.5. -4 plus 5 is 1, divided by 2 would be 1/2. So the midpoint, if you graph it out, would be located right there. And hopefully if you do it, you can check, and it is on that line, and it is right between those 2 points. And the other type of problem that I gave you with midpoints dealt with if you have the midpoint and you want to figure out one of the endpoints. If you have the midpoint and one of the endpoints, you want to figure out the other endpoint. So like you're on a graph here, you have this point, and you have the midpoint. You want to figure out maybe what this point is. Okay? So you're still going to use the formula, the midpoint formula. And let's see. So to get let's use that formula. So to get the x value, we'll just use purple here. So this would be the x, and this would be our answer. Or this would be the formula up here for the x, purple. So let's say the midpoint we have for our x's, the midpoint is 2, so we're going to have 2, this is for the x value again, is equal to, we've got to have the x1, which we have the x1 is -4, plus the x2, all divided by 2. Okay, and for the y, I'll use red. There's our y value, and we got it right there, for our y up here. So our y value in this example, we know is going to be -2, or sorry, -5. That's a funky looking y. Y equals -5. I'm gonna erase this. We'll go back and say y is going to be -5, but that's equal to, how we found that would be using that formula, and we had the first y values, -3 were given. We want to figure out that other y value, And we can just use, we can solve both of these equations here. So for the x value, we want to get the x by itself. So we have to first get rid of this whole big fraction. So let's get rid of the denominator by multiplying both sides by 2 over 1. And so that's going to leave us with 4 equals negative 4 plus x2. And when you add 4 to both sides, you end up with 8 equals x2. So our x value, our original x value for the coordinates of f, I'll put that up here, is going to be 8. And we'll still figure out that other one yet. So in the red here, we're going to multiply both sides by 2 again. 2 over 1 to get rid of that fraction portion. And bring that over here. Because, and again, this cancels out with that. That's why we do that. So we have negative 10 equals negative 3 plus y2. Here we'll have to add 3 to both sides. And get y2 equals negative 10 plus, that's going to be negative 7. So our y value is negative 7. Okay. All we did was plug in what we had for the midpoint formula, and I broke it down by the x in purple and the y in red, so we pulled that formula kind of apart here. But we then solved for the missing y value and missing x value, which is coordinate f here. All right, that is just a recap of the midpoint. I'm not going to recap the distance formula. If you like, this is what it is, written down right here. They're given 2 points you can plug in to find the distance between those. But I'd rather get here to this main portion, which is dealing with perimeter, area, and circumference. And so 2 key terms here. First one is perimeter. Perimeter, you should know by now, is the distance around a figure. If you're having sides, it's the sum of all the side lengths. If it's a circle, it's just this, how far around that circle it is. Area, on the other hand, is the number of square units enclosed in the figure. So it's inside of the figure. So if I were to draw a picture up here, and just a little, let's say this is our box. If we're looking for the area, we'd be looking inside. If we're looking for perimeter, we'd be looking on the outside. All right. So that is area and perimeter. Now, what things do we have to be able to find area and perimeter for this section? Well, it's the basic ones. So we'll start with square and then triangles are 2 basic ones. So the formula is worth knowing, and you'll have to be able to use these. These are ones that I would say you should have memorized, are these basic ones. If we do some more in the future that are not so basic, with different types of parallelograms and such, those you won't necessarily have to have memorized, but these you should have memorized. So to find the perimeter of a square, add up all the sides. So 4 times the side length, whereas the area would be whatever the side length is squared, since they'll all be the same side length. Triangle, add up the 3 sides for the perimeter. And for the area, it's 1/2 base times height. If you don't know why it's 1/2 base times height, it's because basically a triangle is going to be half of a square or a rectangle. So if that's a triangle, it's half of a rectangle. That's why we're multiplying it by 1/2. All right, there's 2. We have 2 others. One is a rectangle, very similar to square. We'll say that it is, we'll leave it at this one. 2 times the base plus 2 times the height, or just add up all the sides for the perimeter. And the area of a rectangle is just the base times the height. For a circle, and I'll put both of them around here. I'm not sure how you learned it, but a circle, to find the circumference, it's the diameter. So this distance right here, this whole diameter, times pi. or it's 2 times the radius times pi. But the area, or the area of a circle is pi times the radius squared. So those 8 formulas you need to know for this section. All right, let's do some stuff with the perimeter. Here we got one example. I think this one is in your notes. It says Mrs. Henderson wants to put wallpaper border around her living room. The room is 18 feet by 22 feet. How many feet of border are needed to go around the living room? So we're dealing with perimeter here. So what is the perimeter? Well, draw a picture. That's what I would do. So if I would draw a picture, I've got the shorter legs are going to be 18 feet. Longer legs are 22 feet. We know that, and I'll use this for the sake of new visuals that you've seen with diagrams. This side length is the same length as this side length. Since those are both one dash, we'll make these 2 dashes. That would be the same side length as each other. So to find the perimeter, you can add up all 4, or you can say 18 times 2 plus 22 times 2 would be the perimeter. That would mean that 36 plus 44 equals 80 feet around the living room. All right, here's a challenge example for you. This is one that I'm not going to go through right now. You can try it on your own. I would actually suggest trying it on your own. But it says graph the figure on the coordinate plane and find the perimeter. So I'll start it off for you. We'll graph it. So -3, 1, that would be point D. 1, 2, 3, and 1. That's point D. -3 and 3, that is point E. And 2 and 3 would be point F. Now, 2 of these side lengths are going to be easy for you to find, but the slanted one, and that's why I like this one, you're going to have to use a certain formula we learned yesterday to figure out the distance of this side here, the side D, oops, the side DF. All right, find that perimeter. All right, but I'm going to move on, and we're going to do some perimeter of a circle. So perimeter of a circle. So something about the circle. A circle is named by its center. There should always be a center point of a circle. It gives you a basis of where you can start things. It's also how you name a circle. So how you would say this is the circle below would be circle C. So it's just a circle with a center point in C. Now, a couple examples of finding circumference and area. So circumference, we said, was pi times diameter. Area of a circle, we said, was pi times the radius squared. So if we move down here, let's find the circumference of each first. So do circumference here, would be pi times the diameter. This whole diameter is 8, so we're going to say 8 pi centimeters. This one, we only have the radius, which is 9, so that means the diameter would be 18, and the circumference is 18 pi centimeters. You notice it says there, give it in terms of pi. You're probably used to doing typing in your calculator 8 times pi, or estimating and doing 8 times 3.14, so it's going to end up being like 24 point something or 25. But a lot of times in geometry and upper level math, we leave things in terms of pi, because we do a lot with pi. So for this, it says leave in terms of pi. You can leave it in terms of pi, and that's all you have to do for the circumference. Area, on the other hand, and we'll do this. So the area for each one, let's see, we need the radius. So the radius for this one would actually be 4. So it would be 4 squared times pi, which would be 16 pi centimeters squared, because it's still area, so you have to do centimeters squared. And the area of this one, we already have the radius, so we have 9 squared times pi, or 81 pi centimeters squared. So that's finding the area and the circumference of a circle. Now the last thing is just finding the area of a regular rectangle, or sometimes triangles or squares. But I'm adding a little twist to one of these, and that twist is in the area addition postulate. So why don't you take a moment to look in your notes and read that one through. It just so happens that I have mine right here, so I'm going to pull it out here. Postulate 110, the area addition postulate says the area of a region is the sum of the areas of its non-overlapping parts. Okay, so if you look here, number 7 is this one's not so much using the area addition postulate as much as it's well, it kind of is backwards though. We're not counting that middle part. So you can probably guess, to find the area of this one, we want to find the area of the whole thing, and subtract the area of the inner rectangle. So we're going to do the area equals the area of the whole, which is 18 times 12. We're going to subtract the area of the middle part, which is 3 times 4. So I'm going to pull my calculator out here. Right now I don't have area 18 times 12 in my head. I could probably figure it out. But 18 times 12, looks like we get 216. So that'd be 216 minus 12, which would be 204 centimeters squared. So is the area of this shaded region. All right, I think you have number 8 you can try on your own. I'm going to skip to number 9. Number 9, we're given a bit here. So now this is where the area addition postulate kind of comes in more helpful. You need to figure out a way to find the area of this. So what I'd like you to do is find the area, tell me what it is. Go. All right, so whether or not you think you got it, here's what I'm going to do. I'm going to break this into easier sections. So I'm going to make this one big rectangle, so that I know part of it is 4 times 12, which is going to be 48. And it's feet squared. Now, you can tell that the height of this thing right here is going to be 4. And that's because there's the dashes here that would mean that these would be equivalent or equal in measure. This one is also 4, so that makes this one 8. And then you have enough to find the area of that rectangle. So the area of that rectangle would be 4 times 8 divided by 2, which would be get you to 32 divided by 2, which is 16 feet squared. So to find the area of the whole, you do the 48 plus the 16. You end up getting 64 feet squared. Alrighty, so that is our little bit of geometry dealing with area, circumference, and perimeter. It looks like we have one closing question that I'd like to take a look at. It says, which has greater area? A solid with side of length 3 centimeters, sorry, a square with side length of 3 centimeters, or a circle with diameter of 3 centimeters. I don't know which one has a greater perimeter or circumference as well. So you gotta know what is what. Best way to do it for me is just to, oh, what happened here? Alright, best thing to do for me is just to draw the picture. 3 by 3. The area is 9 centimeters squared. Perimeter would be 3, 6, 9, 12 centimeters squared. Or a circle with a diameter of 3. So that whole thing is 3. So the area is 9 pi, it'd be 3 squared pi, and that's definitely greater. And the perimeter would be 3 pi. Oops. So let's say that's approximately equal to 28. Let's just say 28. That's my estimate. So this one has the greater area. Perimeter, we have the diameter. Ooh. Back up here. I knew this didn't seem right. Remember, area of a circle is the radius squared. So the radius would be 1.5. So we have 1.5 squared pi, whereas the perimeter would be 3 pi. And I'm going to use a calculator to check this. So 1.5 squared would be 1.5 times itself. And that's 2.25 times. Right now I'm just going to use 3.14 in this one. But that'll give me about 7. So this one is not bigger. Let's take a look at this. Spin it around. So the area of the square is bigger. Now let's check the 3 pi. I think I can make this. There you go. It would be 3 pi times 3. 9.4-ish. Alright, same thing goes here. The square has the greater perimeter. Alright, and this one has actually circumference. Alright, but that is working with both area, perimeter, and circumference here. I hope this made sense for you. It was meant to be a good review. Make sure you are ready for this and can excel with finding perimeter, area, and circumference of basic shapes. Alright, we'll talk to you next time.